Plane. A plane in 3D space is uniquely determined if, for your syllabus, you have two cases. First, a plane in space has a normal vector n. Okay, that is consists of component AI plus BJ plus CK and passes through the given point. Okay, this is fixed point A, coordinate A1, A2, A3. Okay, let's say this is a plane. Plane consists of point A, coordinate A1, A2, A3, and a vector n, normal. Normal means that n is perpendicular to the plane. This is plane. Okay, this is vector n. Vector n, normally we call that one component AI plus BJ plus CK. Okay. Number 2. A plane passes through 3 given points. Okay. Let's say on the plane, okay, 3 points lie on the plane. Label as coordinate A, B, and C. This is 3 points. Plane. Given a plane in a space has normal vector n and passes through the fixed point A, okay, let R is any point which lies on the plane. Since n is perpendicular 90 degree to a plane, then we call then n is perpendicular to AR. Okay, so this is plane. This is A. A lies on that plane. Okay, R is any point which is also lies on that plane. Okay, n is a normal to a plane or perpendicular to the plane. Okay, this is form 90 degree. Okay, using the formula vector A dot vector B is equal to modulus vector A modulus vector B cos theta. Okay, now between the two lines, this is 90 degree. Theta is equal to 90 degree. 90 degree cos 90 degree is equal to 0. Okay, therefore, to show the two vectors perpendicular, we need to show A dot B is equal to 0. Okay, so A is one vector, which is AR, vector AR, dot B. B is a vector which is perpendicular to A. So now here is, this case, B is equal to N. So we can say that A vector AR dot vector N is equal to 0. Okay, we want to show AR, vector AR is perpendicular to vector N. Okay, then, so vector AR comes from vector OR, position vector OR, okay, minus OA dot N is equal to 0. Expand, I will change to OR to vector R, OA to vector A dot N is equal to 0. Okay, expand, then we get A vector R dot N minus A dot N is equal to 0. Then simplify. Okay, therefore R dot N equals A dot N. Okay, you have to remember this is the equation for a plane. Equation for a plane. Okay, so let P is equal to vector A dot N. Vector A dot vector N. When the two vectors dot product or scalar product, we get a scalar. P is a scalar, lambda or scalar or constant. Okay, so here we use P. Okay, this is P. Okay, you can remember that R dot N is equal to P. This is important. This is very important. So we will say that a vector equation for a plane This is the formula. Okay. Okay, from R dot N is equal to P. P is constant. Okay, N is a vector which is perpendicular to the plane. This is plane. This is vector N. N normal or perpendicular to plane. Okay, R is any vector. Okay, which is lie on the plane. A is fixed point. Okay, so replace R dot vector N. N is consists of component AI plus BJ plus CK is equal to P. Okay, then let's say R is any point, any coordinate X, Y, Z. Okay, and substitute position vector R into this formula. Then do the dot product. Okay, the product. Okay, still remember dot product. X, Y, Z dot A, B, C is equal to P. Component I, okay, A, X plus component J, B, Y plus C, Z is equal to P. Okay. And then, okay, this is called Cartesian equation of a plane. Okay. Okay. So, for example, okay, now you remember that, okay, when say R dot N equals A dot N, this is vector equation of a plane. Vector equation of a plane. Okay, read in the full sentence. A plane. A plane. Okay, we say that AX plus BY plus CZ is equal to constant P. This is Cartesian equation for a plane. Now, example 1. Find the vector equation of a plane, this one, okay, which contains a point, some point, A, we call this one point A, fixed point, and perpendicular to the line, L. Okay, so this is a plane. Okay, plane. This is point, this is A. Okay, let's say this is A, point A, -2, 3, 5. And okay, for a plane, just write a formula. Okay, formula for vector equation for plane. R dot N equals A dot N. Okay, so now you need to find A. Okay, this is A, vector A. And N, which is the vector with normal to the plane, N. We need to find vector N. Okay, and we need to find N, and A is given. Vector A is, okay, -2i plus 3j plus 5k. Okay, the problem now to find vector N. N is normal to plane. Okay. Okay. So L. Okay. L is perpendicular plane. This is L. Okay. L is perpendicular to plane. Okay. Inside L is vector equation of a line. So remember the formula. R equals A plus TV. Okay, means that for L, we just concentrate on V, a direction vector. A vector which give direction to line. So this is also V. Okay, or V is outside the line, but parallel to the line. This is V. Okay, so when line L is perpendicular plane, okay, from the diagram we can see that N, this is vector N, also perpendicular to plane. Okay, so between connection between vector N and vector V, we can say that vector N is parallel to V, or we can say that vector N is equal to V. Okay, this is vector V. So V is equal to 3I minus J plus 2K. Or we can say that this is equal to vector N. Okay, then substitute in the formula. Okay, substitute the formula. R is any vector, just write R. N is V. 3I minus J plus 2K is equal to vector A is negative 2I plus 3J plus 5K dot N. N is equal to 3I minus J plus 2K. Change to matrix form, negative 2, 3, 5 dot 3, negative 1, 2. Okay, find dot product. Negative 2 times 3 is negative 6 plus negative 3 plus 10 is equal to 1. So, this is the answer. Just write down R dot 3I minus J plus 2K is equal to 1. This is called vector equation of a plane. Okay, settle for example 1. Example 2. Example 2. Find a vector and Cartesian equation of a plane which contains the 3 points. Okay, so this is the plane. Okay, on the plane consists of 3 points. A, coordinate B, coordinate C. Okay, given 3 coordinates. Or you can change coordinate A to position vector negative I plus 2J. B, vector B, 3I plus J plus K. Vector C, I plus 3K. Okay, from the given coordinate change to, this is called position vector. OA, OB, OC. Okay, so now to find a vector equation of a plane, okay, write down the formula. This is the formula. Okay, from this formula, you need to find R, no need to find because R is any point which lies on the plane. Say that this is R. Okay, we don't have to find R. Okay, and vector N is a vector which is perpendicular to the plane. Vector which is perpendicular to the plane. This is N. Okay, we need to find vector N. And this A is fixed point. You can take coordinate A or B or C. Any point which lies on the plane. Okay, so our problem is to find N. To find N, okay, we need to do cross product between the two vectors. Okay, because of only cross product produce a vector which is perpendicular to this vector. Okay, to find this vector, okay, you need to join the two coordinate, the 2 points. Okay, so you can take any. Okay, if you take A, C, okay, A to C, here also suppose A to B. Point out, out. Okay, you can take A, C, and A, B. Or if point in B, A, B, A, cross C, A. Okay, any point. Okay, or anything B, C, B, A. C, A, C, B. If the point both out, out. In, in. Let's say I take A, AC, coordinate AC, vector AC, and vector AB. Okay, so we want to produce vector N, which is perpendicular to vector AC and to vector AB. Okay, next find AC, AB. AC, vector AC is equal to C minus A. C minus A. Okay, vector C minus vector A. Okay, I minus I, so 2I. Okay, minus 2J. 3K minus cos, okay, 3K minus, this is no K, plus 3K. Okay, this is vector AC. Okay, then find vector AB. B minus A. Vector B minus A. 3I minus 4I. J minus 2J, okay, J minus J, so plus K. Okay, so to find a cross product, you need to indeterminate. Remember, the first row always component I, J, K. Okay, at least you can still find vector AB cross vector AC. It's okay. Okay. So AC is 2, negative 2, 3. AB equals 4, negative 1, 1. And find the determinant. I, negative 2, 3, negative 1, 1. Minus J, 2, 3, 4, 1. Plus K, 2, negative 2, 4, negative 1. Then find, give answer. I give you answer. The answer is I plus 10J plus 6K. If you find vector EB cross AC, you will get the negative. Negative I minus 10J minus 6K. Okay, and then substitute inside here. Okay, and N. Because of not enough space, I do this one first, dot product. Okay, A, vector A dot N. Vector A, I take A, okay. Negative 1 to 0. Component K 0. Dot 1, 10, 6. This one, okay. So, negative 1 plus 20 is equal to 19. This is 19. Okay, then substitute. Okay. R, just write R. Dot N. N is vector I plus 10J plus 6K is equal to A dot N. A dot N is equal to 19. Okay. So you can leave answer in this form. Okay. So settle this one. Okay. Now we want to find Cartesian equation. Okay. Cartesian equation. Vector R. R is a vector which is X, Y, Z. X, Y, Z. R. Dot 1, 10, 6 is equal to 19. Expand X plus 10Y plus 6Z is equal to 19. This is Cartesian equation of a plane. Okay, okay, or you can see the solution given. Okay, now here find that vector AB cross vector AC. Okay, and normal. Okay, find AB, vector AC. Then find N. This is N, vector N. Okay, do the determinant. Get the C negative. If you find vector AC cross vector AB, you get positive I. plus 10j plus 6k. Okay. And substitute in the formula vector equation of a plane. Okay, taking A, also A, you can take B or C, they get the same answer. Okay. Substitute A dot n is equal to negative 19. Okay, then this is vector equation of a plane. Or you can leave answer in positive I plus 10j plus 6k is equal to 19. Okay. Okay. Then the next step, substitute R is any point xi plus yj plus zk. Substitute on the left hand side of the formula vector equation of the plane. And then you get this one. And this is called Cartesian equation of a plane. Okay, settle for this example. Example 3. Find the vector equation of a plane contains lines. Two lines. Contain two lines. Okay, if you sketch the diagram, this is the diagram. So this is plane. Okay, this is line. So this is line 2, line 1, line 2, line 1. Okay, inside the line 2, we get this one. This is V. V, call this is V2. V is a vector, give direction to L2. V1 give a direction to L1. Okay, this is. So for a line, you just take the vector, this vector, this vector, this vector to show a line. Okay. And then, okay, for a vector, okay, this is plane, this line L1 or V1, L2 or V2. Okay, for vector equation of a plane, you need to find R dot n equals A dot n. N is a vector which is perpendicular to plane. Okay, to find n, you need two vectors which is lie on the plane. Okay, so this is the formula. You need to find n. N, a cross product, a vector, any two vectors which lie on the plane. So the two vectors V1, V2. Okay, V1 is equal to, V1 is equal to I plus 3j minus 3k. V2 is equal to I plus 2j minus 4k. Okay, and do in determinant. I, j, k. V1, okay, 1, 3, negative 3. V2, 1, 2, negative 4. Okay, this one, okay, component. Then do the determinant. Answer is negative 6i plus j minus k. Suppose you get this one. Do yourself. Okay. So, okay, now we already have n. Substitute r dot n. Negative 6i plus j minus k is equal to, okay, the problem now is to get A. Okay, to get A. A is a point which lies on the plane. Okay, so here we don't have A not given. Okay, here A not given, but L2, L1 lie on the plane. L2, L1, formula for vector equation of the line is A plus TV. A is a point which lies on the line. Here and here means that this point also lie on the plane. You can take any value, A from L2 or A from L1. Okay, let's say you want to take A from L1. A is equal to 2I plus 2J minus 4K. Okay, you can take anyone. So substitute 2I plus 2J minus 4K dot N. N is negative 6I plus J minus K. Okay. Okay, now on this side, change to metric form. Dot product, negative 6, 1, negative 1. Okay, 2 times negative 6 plus 2 times 1 plus 4. Answer is negative 6. So, you can say that R dot negative 6I plus J minus K is equal to negative 6. This is actually vector equation of a plane. Okay, that's it. You can leave answer in this form. Okay, settle for example 3.